yesterday would work, but I guess it didn't. All right, so most important, you are looking at endless quadrants. This is completely the opposite of your restricted domain. So we're looking at endless. And I said if you could give me the all solutions. Did I say that on your paper? I didn't say it, but I think I tried to add it. Okay, so we went over the first two and we said you're going to have to just plug them in. You could solve it if you like. You could solve the equations to see that they work. You could plug them in. That'd be the easiest. Put your moles in radians and put it in there. If you'd like to convert them to degrees, you can do that too. Same thing with this one. When you're doing a secant, if you solve secant x equals, then take its reciprocal. Do the cosine. Plug it in using 1 over cosine when you do the secant, and that works too. I think the only one that sometimes doesn't work is a tangent. When you do a 1 over a tangent, because sometimes a tangent can be a 0, so it can't then flip that over. So that's the only one that probably won't work sometimes. Solving, so let's get to the solving part. Can you guys see this okay? It's kind of light. Okay, so you're going to solve like a regular equation. Solve the algebraic part. So you get sine x is equal to negative 1/2. Now we're in the trig part, where sine, which is y, negative 3 and 4. It's the same as coming off of a circle. The shortcut, just drop your triangles. The triangles have to be the exact same, so just label one of them. Find it, as long as you know this is a 30, then just find your reference angle. And then divide it into 180 and figure out your angles. Because the period for sine is 2 pi, then you're doing this. Because I can't go every 180 because it's not over here. It's down here. So I have to go every 2 pi and come back around and come back around and come back around. So it just gives us an endless solution set. This guy, same thing. Recognize this as your 45. These are all having to come back, all those special right triangles. Okay, sine again, negative and 3 and 4. Now we have a 45-degree angle. Everybody okay with this? Okay, stop me if you have any questions, please. Because this is really, really important. This is the real basic part. They all work like this. We just kind of glorify them a little bit. We put factoring in there and some other things in there. Multiple angles we'll throw in there. We'll do a couple of other things with this. Ugh. All right, the next two, again, solve for the secant. You should recognize that, guys. You don't, once you get to the secant part, once you get down here, because it'd be like, what angle had a 2 over radical 3? Flip this over, take its reciprocal. That should ring a bell. I mean, you can set this up, r over x, that works fine. If you struggle, go the x over r routine. Cotangent. Cotangent, now their period for cotangent and tangent is pi. So now I'm able to come straight across. So if I hit this one and go here, I will hit that one. Then I go here, I will hit this one. So every pi now. So we set this up n pi. Because their period is every pi. Yes?
You don't have to include the 7 pi over 4.
No, because if you do the 2n pi, then you're going to have to do them both separate. If you do this one and just do the n pi, you hit all the angles. Because you come straight across the pole. I would like you to do this. I mean, it's not wrong because you're still hitting all the angles by saying 2n pi. It's coming full cycle around. But you could avoid it and do n pi. It's not wrong, but I would like you to try the n pi on this. Try to go by the period for this. It's going to be important when we do multiple angles. And these probably are, nope, not your last two. Again, we have a secant. This is really, really important. When you take the square root, you get a plus or minus. A plus or minus gives you all 4 quadrants. 2 negatives, 2 positives. Flip it over. Make it a cosine, plus or minus. Find your one reference angle. That's all you have to find. Now, because this can go across the pole this way, you can take care of this one and this one together by saying plus n pi. You don't have to write 4 of them out, plus 2n pi. Even though the period is pi, you're using every quadrant for this because it's plus or minus. Because if you could see that you have one triangle here and then straight across, 180 degrees across, 180 is like a complete turn, half turn this way. So if you can make a half turn, you can do the n pi. That's why tangent and cotangent come straight across the pole, the origin. They come straight across. So you can do this one and this one together, this one and this one together. If you gave me all 4 with 2n pi, it's not wrong, but you could avoid it and condense it. The plus or minuses are always going to happen like that because now you're using all 4 quadrants. Remember, you always have 2 negatives, 2 positives, so that covers all 4 when you do this. Again, cotangent, you can do the same for this one. So just watch when you undo a square, you get plus or minus. And your last one down here, this was a cosine plus or minus. Again, hit the first quadrant. If you hit the first, you account for the third. God bless you. The second one that you reach, going from left to like going around in your full circle from right to left, kind of counterclockwise, is quadrant 2. You can't give me quadrant 4 because you'll never get back to 2. Because we only do this on the positive. Well, actually, this takes care of it when you take any integer. It'll do the negatives, but I would like you to start with the quadrant 2 one. You will hit it because we can use any negative integer as well. So, yeah. What 2 functions do you see in here? Cotangent, cosine. So if I make this an x and I make this a y, something's wrong with my board. This will also be an x. So let me just take this out for a minute. X squared equals 2x. How are we going to solve this? I don't know. Okay, get everything to one side. As soon as you see variables over the place, get everything to one side. So subtract the 2x. So let's subtract the 2 cotangent. We're just going to do the same thing right here. I made the x be the cotangent, I made the y be the cosine. And since our cosine was squared, I made it y squared. I just took out the trig part of it. So let's subtract that. Okay, now what? How do we solve this right-hand side one? Well,
Factor out of that.
good. Factor out an x. That's what they have in common. Now I have 2 sets of factors. Now I could set these equal to 0. They're 2 variables in one equation. But if I can factor them and get my factors so that they set this way, I can certainly solve them, right? I can add 2, take the square root, so let's just add 2 first. Take the square root. Remember, you're going to get a plus and a minus. Okay. So how many solutions do you see? 3. So I have 2 here, 1 here. Okay. And I could plug those in algebraically and make sure they work. Agree? Okay. So let's do the same thing over here. What can I factor out? Cotangent. Works the same way, right? So now I have 2 factors. If it helps, put your factors like this. This way you recognize them as those products. Set them both equal to 0. I have an angle whose cotangent is 0. So that part's done, just like this part was done. I have to add 2. I have to take the square root. God bless you. So it kind of looks the same, right? So far, algebraically it looks the same. All right, so now all I have to do is the trig part. I did the other part, now I got to do the trig. So let's go to cotangent. I notice it's a 0. It must have come off my quadrant angles. Remember, any angle this can be. Does this say what to solve in? So we'll just make it any solution. Now, cotangent, my tangent does y over x. God bless you. So what does my cotangent do? X over y. So if I'm looking for it to be a 0, which one of these has to be a 0, the x or the y? The x. If I make the y a 0, it's undefined, right? So I need my x to be 0. So this guy's a 0, this guy's a 0. Agree? X over y. I can't divide it the other way, because then it's undefined. So right now I have two solutions. I have a solution where x is pi over 2, and x is 3 pi over 2. If I was only in 2 pi, those would be my solutions. But if I want all possible solutions forever, aren't these right across the pole? Aren't these 180 degrees apart, pi apart? So I could take my first one and say plus n pi, where n is any integer. Good so far? Okay, now I got to work on the other part of it, because I got two factors here. So now I'm going to look for an angle whose cosine is plus or minus radical 2. So what quadrants will this fall in? Or could this fall in?
Why'd you cross that one out?
Because if we just do this one, going n pi, because it's a tangent, period is pi, we can hit the other one. So we only really need to do one, because the cotangent and the tangent just have a period of pi. So technically, all 4 quadrants, I should look at this, right? So I say, okay, all 4. I say cosine is x over r. What's my reference angle? Chris doesn't like this. Can't do it, right? Can't do it. What is wrong with that picture? The leg is greater than the hypotenuse. Can't have a cosine greater than 1 or less than negative 1, right? Isn't the range negative 1 to positive 1? So does this angle exist? No. So this is undefined. Or rejected. You could say reject. We can't do this. There is no angle for this. It's such a waste. So we have one solution to this. Now, over here, algebraically, we still get two sets. We don't know algebraically until we look at the trig part. Okay? And that happens. Try to remember that your range for sine and cosine are negative 1 to 1. Your range for your reciprocals and your cotangent tangent are all real numbers, or not all real numbers, but there you go. The tangent and cotangent are all real numbers. Your reciprocals are from 1 and above and negative 1 and below. So try to remember those as you go through this. Okay. All right. So let's hit the next one. A little bit of factoring in here. So my variable, what function do we have, if any, or do we have more than one? Just the sign. So I'm going to take this out right now and just replace sine with an x. What would I do to this trinomial? Factor, how? Well, I don't really have to do that because these are both prime numbers. So this only has factors of 1 and 1, right? So start like that. And 2 only has a factor of 1 and 2. So I'll just go like this. All that I need to worry about is my sign in the middle. I need my sign so that I multiply the negative by the higher number. That works fine. That works fine. But this one you don't really have any other factors, just these. So watch. Just go like this. These guys, the little smile guys, give you that inside number. So which one of these should I multiply by a negative? This is going to give me 1x. This is going to give me 2x. Which one do I need to be negative to end up with a negative 1? The 2x. So therefore, this guy has to be a negative. This guy has to be a positive. I need my middle numbers, my middle terms, which makes my smile, to come out to be negative 1. So when I multiply this, this is where I put the signs in here. This would be a 2x. This would be a 1x. I need the 2x to have the negative sign. So therefore, I have to multiply this guy by a negative. If I did this, say I put it the other way. This is going to give me a 1x. This is going to give me a 2x. I need the difference here to be a negative 1x. Oh, so this guy's got to give me my negative, so I have to multiply him by a negative. No matter which way you set that up. It's only one way you can really make a mistake, by putting a sign backwards and then just flip the sign. Because both of those numbers are prime numbers. They only have one set of factors. Actually, one is not a prime. One is not a prime. So it only has 1 and 1. So let's set this up. So now I know I've got 2 sine x plus 1 sine x minus 1. And if you like a times c, by all means, use a times c. So we've got 2 set of factors. And that's the hardest part. The rest is what we've been doing. So now I have to get to finish my algebra part. Subtract the 1, divide by 2. Add the 1. The sine squared, what about your x squared? What did we do to your x squared? X and x, right? So your sine squared, we had to go sine and sine. So if it helps, write it first without the sine and the cosines in it. Look at it that way first, and then do the same exact thing that you did. Sometimes it gets confusing with the sign words in there, especially if you're not really comfortable with factoring. You see all these things in it, especially when we hit a cosecant or a secant, and that really throws everybody off because that's not a favorite one either. Like, sine is okay, cosine's okay, but secant is not. So pull it to the side and do it with an x. Let's concentrate on this. Sine is my y. Where is my y negative? What quadrants? 3 and 4. So I set this up y over r. What's my reference angle? 30. How many times does 30 go into 180? 6. So this is 6 pi over 6. This is 12 pi over 6. So my answer will be 1 more than 6. And my answer will be 1 less than 12. So again on this guy, our cycle is 2 pi. So I've got to come around to n pi. Oh, is that we want till 4 pi? Thank you. So we don't have to do this. So let's just, because we only have to go 1 more cycle, let's just keep going with this over here. I did 6, I added 6, I should add 6 again. 18 pi over 6, I should add 6 again. So now I only have to go to 19 pi over 6, which is the same as adding 2 pi to that in terms of 6s. Because if I add 2 pi and I convert that denominator to 6, isn't that 12 pi over 6? So aren't I adding a 12 to this? Just deal with your denominator being the same. And I can add a 12 to this. 1 more, 1 less than this. So I have 4 solutions in 0 to 4 pi. Now let's hit this guy. For my signs, my 1s and my 0s fall where? They're not triangles. They're quadrants. Quadrant angles. Is the sign the x or the y? The y. So what angle has a sine of 1? 90 degrees. So I just have to go from 0 to 4 pi. So I only get one angle in all of 2 pi, right? So let me just count by halves. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So I have these solutions. Pi over 2, 5 pi over 2. I don't care what order you put these in. I would like them highest to lowest, but if you like to group them like this, this is even easier. I'm okay with this. Go.
Where did you get the pi over 2, 5
Pi over 2, we said the sine of 90 is 1. So that's pi over 2. So since I have to go to 4 pi, I only have 1 and 2 pi. I'm going to get 1 more. So rather than add 2 pi to that guy, which I could say n pi over 2 plus 2 pi, I have to convert this denominator to 2's because I'm adding fractions. So this will give me 4 pi. So 1 pi and 4 pi give me 5. Where's my 5? 5 pi. But easier because I'm only going to go one more time around. I'm just going to count by halves. So this is half a pi over 2, a full pi over 2, one. Let's see. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I'm only going to go around it one more time. But you're going to get 4 solutions to that whole equation. You can throw that in your calculator and check it. It's an algebraic equation. The factoring, I know the factoring just makes it just a little bit tougher. Is there one more to this? Yeah. Oh, yeah. This one should be a little bit of a difference here. Okay. Now, I got a little problem here. I have 2 different functions. So technically this looks like this. Can I do anything with this equation over here on the right? No. Unless I have another equation where I can substitute out for y or x, I can't solve it, right? So we don't have to do it that way, but we have to find an equation that we could substitute one of those out. This one's not going to help us, but this one, we have one trig identity that's going to help you on this. And when we did your unit circle, and this was 1, we said this was the x, right? This is the y. Pythagorean theorem says this. On your unit circle, x is the cosine, y is the sine. So we have a Pythagorean identity here that's going to help us for this. You got to know this one. This is the one you have to know. The rest, the secant and tangent things, we can remember. We can divide all of those by cosines. We can divide all of them by sines. But this one, you have to know. So if you have to memorize one of them, memorize that one. I can't replace a sine. I can't replace a cosine. Those are my basic functions. I can replace a tangent by saying sine over cosine. I can replace a secant, 1 over cosine. I cannot replace a cosine or a sine unless I use Pythagorean's identity. So if I want to get one of these out and solve it in terms of the other one, I can do that. Now I can't replace my cosine without the square. That's a basic. Can't get rid of that guy. I can substitute out sine squared. If I come here and I solve for sine squared, there's my second equation. Systems of equations says 2 variables, 2 equations. I just found my second equation. So my sine squared is equal to 1 minus my cosine squared x. And if I subtract it the other way, my cosine squared x would be equal to 1 minus my sine squared x, right? So those are the 2 that I want you to remember. There's no getting around this. Those are the two you need. So now if I take out my sine squared and I substitute this in, I get agree? I just substituted out the sine squared in terms of cosine. So am I not going to have one equation with one variable? It's going to have a square on it. I'm going to have to do some factoring. First, I got to clean my house up a little bit here. I have to distribute. Now, here's your equal sign. Collect your like terms on the same side of the equal sign. Put it in descending order as well. So which term is the highest exponent? So I got to put my negative 2 cosine squared here. Then I'm going to go to the next highest exponent, which is what? 1. So I'm going to do the 3 cosine x. And now technically there's a 0 because 0 makes it 1. So I'm going to combine a 2 minus a 3. I'm on the one side of the equal sign here. Don't go minus 2 because the equal sign is on this side here. So what's a 2 minus 3? Negative 1. Now we learned when we factor, our leading coefficient should be a positive. So I'm just going to divide everybody by a negative 1. I'll bring it over here so that I can get my leading coefficient as positive. It just changes the signs. And now I have to factor. And again, if you struggle with factoring, take out the cosine and see what you would do. This again has to be a 1 and a 1. Now, notice the signs here. God bless you. I've got a positive here. When I multiply, I'm going to get a positive, but when I add them up, I'm going to get a negative. So what are my signs? Negative, negative. So I'm negative, negative. Does it matter which one says 2 cosine and which one says cosine? I got it made. I'll make this a 2 cosine. I'll make this a cosine. And now we're doable. Right? So we set this equal to 0. I add 1, divide by 2. I set this equal to 0. I add 1. And now I find my angles. Okay, is this also 4 pi? It just says solve. Okay. So we'll do 4 pi on this one too. All right. So I'm going to find my cosine, which is my x. My x is positive in what quadrants? 1 and 4. Here's my x-axis right here. This is my positive x. 1 and 4. I am restricted to 1 and 2. But I'm positive in 1 and 4. Okay, so 1 is my x over 2. This is radical 3. What's my reference angle? 60. How many times does 60 go into 180? 3. So this is 3 pi over 3. This is 6 pi over 3. So I've got x is equal to 1 pi over 3. Plus, if you want to do the plus 2n pi, if you're going to do that. And x is equal to, what's this guy? The quadrant 4? 5 pi over 3. Good. So if we were doing this, we'd say plus 2n pi, where n is any integer. We'll do the 4 pi in a second. So everybody okay with that so far? So if we did from 0 to 4 pi, from here, x is pi over 3, x is 5 pi over 3, that's a 5. But my board is a little bit off here. So if I'm going to do this again, I'm going to say this is 3, 6, 9, 12. So I'm going to come around. After I come here, 3, 6, this would be a 7. This would be an 11. Okay? And then do the cosine one. Cosine is 1. Sounds like a quadrant angle to me. You're right here. This guy's a -1, so that won't work. So you're at the 0. 0 is also 0 radians. 0 degrees, 0 radians. If I'm going to do it one more time, what do I call this? 2 pi. If I need to go to 4 pi with the hard bracket, then I would have to say 4 pi. But if I'm going to 4 pi with a soft bracket, did we say on the other one? 4 pi with a soft bracket, so you don't have to say 4 pi. So I would also have 0 and 2 pi. These would be my solutions. That probably has like the most work to it. You have to substitute it out and factor. Got a lot going on there. Yes.